Next, we're going to look at graphing these systems of nonlinear equations. Um, we've seen a lot of these principles before, so let me talk you through this. I'm going to be graphing an inequality here, so this does not include an equal sign. If it did, I would graph a solid line, but it doesn't have an equal sign, so I'm going to get this to be a dash. So first of all, if I had y equals x squared, I would just graph this, right? We know this is a parabola. The plus 1 means it's just shifted up 1. So they're going to do a test point here. I'm going to show you another way. So I just have a parabola that's been shifted up 1. It's got a dashed line because it didn't have an equal sign in it. Now, here's the way I think of it. They have a test region here, but I think it's simpler to think of it like this. If you extended this on forever, this line would really keep curving up forever and ever. And what our inequality says is that I want the y's that are greater than that parabola that I've just made. Well, the only place the y's could be greater than that parabola is above them. So we want the area above that inequality or above that parabola that we just made. And so we graph this. Again, a dashed line shaded above the parabola. So this region here in blue. Now we're going to find how to do a system of these. We're going to have two parabolas here if you see how this is done. So I'm going to really quickly change this into, see, if I just send this y to the other side, y is going to be greater than x squared. And then I'm going to do the other one. And we've got y is less than or equal to negative 2x squared plus 12. Okay, so first what we want to do is we want to find where these would intersect each other. So we have some points on the graph where we could see where they hit. Well, this is the same premise that we've been doing before. Now notice I've got minus y and plus y, so I'm going to just add these up. It's already set for elimination. They would just drop off, and I've got 3x squared equals 12. Solve that, x squared is 4, x is plus or minus 2. Now, putting that into the equation, solving it down, I actually get 4 for both of these. So putting in 2 or negative 2 gets me the same thing. So I've got some points of intersection. I've got 2, 4, and negative 2, 4. So these parabolas are going to intersect at these 2 points, which will help me. Now, I've already set this up here. This is just a straight parabola at the origin. So this is the red one. Okay, now if we were to graph this, we could do this other one here by plotting points, but we know it's upside down, so I'm going to do it like, think of it like this. No, I think that would be better to think of it. Yeah, I'm going to stick with what we've got here. So here's what this tells me. I'm shifted up 12. So I've shifted up 12. I'm stretched by a factor of 2, and I'm upside down. So here's I'm up 12, I'm upside down, and here's my vertical stretch. So I wouldn't need to get this vertical stretch exactly right. I know that I intersected these 2 points, I'm upside down, and I get this picture. So the first graph, I want y's to be greater than or equal to that red line. Well, we just saw that. That means it extends forever. I want the y values that are above the line. So I want this red region. Now again, one more thing as I notice it here. This is greater than or equal to. So the red line is filled in, the parabola is filled in. This is less than or equal to, so our blue line is also filled in because it's got an equal. Okay, now we want the y's that are less than this parabola we just made. So that would be, we want all the y's down here, which creates that blue region. And so the solution here would be the intersection of these 2 regions there. Okay, so let's try this again here. So let's find the points where they intersect. We've got this parabola that's going to be shifted down 1. But let's just treat that, well, no, I should do the x. I'm just solving this as if it was an equal sign to see where these are true at the same time. I get x is y minus 1. So coming back to the original, I've got y is, so I'm just finding the intersection, pretending they're equal signs to see where they'll hit each other. So I've got y is, I don't need that, sorry, that was a parenthesis. So I've got, So I move this y over, so this is what I've got, y squared minus 3y equals 0. People have a hard time factoring this sometimes, but it's easy. Just pull out a GCF of a y. Get this. Get y is 0 and y is 3. Okay, let's plug those back in and see what we get here. I'm going to use this. Oh, I should use the bottom one here, use the linear one. So x minus 0 equals negative 1. So that's going to get me negative 1, 0. And then how about the second one? I'm going to put 3 in here. I've got x minus 3 equals negative 1. So I get 2, 3. Okay, so these are the 2 points where they intersect each other at negative 1, 0 and 2, 3. Now, I don't have a pretty graph here for this, but so a parabola at x squared, well, let's mark those points. So negative 1, 0 and okay, so I've got those 2 points. My parabola here is just a normal parabola down 1. So it just shifted down 1. If you don't remember all those, check that old stuff out here. And it's going to be doing something like this. Okay, and now my line here, I've got a line. I should solve it for y instead of x. Okay, so we've got an intercept at 1, got a slope of 1 over 1, and that's how we're getting this line here. Okay, now everything had an equal sign, so everything is filled in lines. Now let's select our region. If I had this parabola, I wanted greater than the parabola, so that would be this region here. And I wanted to be, it was originally a greater than sign. So hold on, this is what we actually had, negative y. We divided by negative 1, so we want less than that line. So when I'm solving this, I had a greater than, but I divided by negative 1, so it turned it around. You see what I've done here? Dividing an inequality by negative 1 flips it around. So I want to be below the line, and that would be, so it's really all of this region, but where they intersect is this blob right in there. Okay, hope that made some sense.